Okay. So there's a couple things I want to say. Now that we've talked about all the different non-covalent bonds, I want to summarize them, and then I want to actually apply them to some real situations. So relative bond strengths. Again, this is in Bio 111 because the chemists will argue about this, but highest is covalent, then to the lowest ionic, hydrogen bonds, hydrophobic effect, and last is polar van der Waals. All right. Now, am I saying that every covalent bond is stronger than every ionic bond? No, there are some weak covalent bonds and some strong ionic bonds. And likewise, they sort of overlap. But this general scheme follows. And we'll use this rule for thinking about things in Bio 111 because it's true almost all the time. The reason I say in Bio 111 is because the chemists will make a fuss. They say ionic bonds can sometimes be stronger or often stronger than covalent bonds. And that's because the chemists are thinking about ionic bonds like in crystal salt. And we don't worry about crystal salt in Bio 111. We're talking about things that happen in water. In water, covalent ionic bonds are comparatively weaker than covalent bonds. So you'll hear other things in chemistry, but we're not really disagreeing with each other. Ours always has like a little asterisk that says in water. Right? So one of the consequences of this, to start with, and then we'll talk about a lot more, one of them is if you put some stuff in water, will it dissolve? Okay. And basically there are two competing forces. That is, you've got the hydrophobic effect versus what you might call stuff, whatever the stuff is, to water bonds. And the idea here is that if the hydrophobic effect is stronger, it will tend to make it so it won't dissolve. It'll stay with phobic stuff, whatever molecule it is. And if you can make stuff to water bonds, things like H bonds or ionic bonds, it will dissolve. So some things it's clear, but what if you have a molecule that has some mixed characteristics? How do you decide? Well, one of the things is, since, and this is what the warm-up is about for Wednesday actually as well, the hydrophobic effect is very weak. Only a few stuff to water bonds are needed to make it dissolve, to make the stuff dissolve in the water. So like again, you're thinking about this, right? Am I going to join the party or not if I'm a molecule? Hydrophobic effect is almost as weak as it gets. Hydrogen bonds are good and strong. So if I can make any kind of hydrogen bonds to you, the water molecules, I'm going to get drawn into the party. It's very likely, unless there's something extremely hydrophobic about me that makes me want to stay with my hydrophobic buddies. So there's a balance between these two, but it turns out atom for atom, hydrophilic things are stronger than hydrophobic things. So if I can make one hydrogen bond, it actually can balance out a whole lot of hydrophobic things because hydrogen bonds are stronger. So what I want to do are some examples. And for this, what you need is today's information-packed handout, so you don't have to try to copy the structures down. So if you turn to the next page of today's information-packed handout, you will see a number of chemical structures. Okay. All right. So here's a bunch of practice molecules. We'll start with the top one. Here we go. So first question, if you look at octane, which is part of gasoline, that thing is covered with hydrogens. It's got that molecule of that, it's got 1, 2, 3, 4, 5, 6, and 6 more is 12 hydrogens. Hydrogen bond city, right? Lots of hydrogen bond possibility, yes? No. Why no? They are not special hydrogens. Those are boring, uninteresting vanilla hydrogens, all right? They are, first of all, although there are plenty of hydrogens, so this is part, let me write this up. This is part of gasoline. It's called octane, by the way, because there's 8 carbons. These are not special hydrogens. Therefore, no H bonds. So this molecule is going to be hydrophilic or hydrophobic. Let me put it this way. Is it going to be able to form nice, strong bonds with water? No. So is it going to join the party, as I said? No. So hydrophobic or philic? Phobic. So this is phobic, big time. All right? So therefore, so this would be a classic example of oil. Right? That is, in fact, it is, if gas is spilled in water, it doesn't mix. If you drew a cartoon of it, it's this long, skinny thing, and there's really just nothing interesting from water's point of view about it at all. Questions? Yeah, Sabrina. So what makes it a special hydrogen? Tell me. What makes something a special hydrogen? Yeah. It's covalently bonded to nitrogen or oxygen. Covalently bonded to something wicked high electronegativity. Let me say it right. So nitrogen or oxygen makes it a special, being attached to a nitrogen or oxygen makes it a special hydrogen. So, for example, that brings us immediately to this molecule. I should put some lone pairs on here just for whatever. All right? So, this guy's lots of hydrogens. Any special ones? Yes. How many? 1. The one on the end, right? Because that's attached to oxygen. So that is a special hydrogen. This can make, this whole group here can make H bonds. All right? Therefore, this part, anyway, of the molecule, is this part of the molecule phobic or philic? Philic, right, because it can interact with water. So it's got something to draw it into the party, as you say. So if you draw this cartoon, a cartoon of this guy might, therefore, this part is philic. Right? If you drew a little cartoon, I mean, this is very, very rough. It corresponds to that sort of little philic tip there on that molecule. All right? Take this molecule, compare it to butanol. So my question is this. It turns out you cannot predict whether something's going to be soluble or not. That turns out to be quite difficult. But you can predict, relatively speaking, more or less. So what I want you to talk about with your neighbor is butanol going to be more or less soluble in water than ethanol, and why? So think about it, talk to your neighbor, there's lots of hydrogens, all that kind of thing. Is butanol going to be more or less soluble? And think about that balance between joining the party and staying with your hydrophobic buddies. All right?